Hello friends, I am Jitendra Kumar. I am taking Power Electronics for the third year student in continuation of the previous lectures, which is based on the DC to DC converters, or we can call it as a chopper. There will be a step up. In the previous lecture we will discuss the types of choppers. Now we will start over the types of choppers: chopper A, chopper B, chopper C, chopper D, and chopper E type. Right? First one we will start over the step up boost chopper. The output voltage is more than the input voltage by several times. Then it is just for that reason it is called the boost chopper. L is used to provide a smooth input current. The SCRs act as the switch which works in the PWM mode. PWM we already discussed in the previous lectures. With S on, the L is connected to the supply. Load voltage VL jumps instantaneously to V input, but current through L increases linearly and stores some energy. When S is open, the current collapses and energy stored in L is transferred to C through freewheeling diode D. The induced voltage across the inductor reverses and adds to the source voltage, which increasing the output voltage. The current that was flowing through S now flows through L, D, and C to the load. So this is the path through which the current will be flowing, right? Energy stored in the inductor is released to the load. With S closed again, D becomes reverse bias. The capacitor energy supplies the load voltage and the cycle repeats itself so that we are getting the V output equal to Vi plus VL. V output is always higher than the V input as polarity of the inductor voltage VL is same as Vi. If inductor L is very large, we can say that the source current II is ripple free and is considered as a constant. So W on means power on, it will be Vi into II into T on. T on means the on time. Assuming C to be large enough to neglect the voltage ripples, V output is considered as a constant. So V off time will be the based upon the voltage, that the voltage must be the V output minus V input into input current and the off time. Since losses are neglected, the energy transfer during T off by Lm is to be equal to energy gain during T on. So W on must be equal to the W off because we are obtaining a fixed frequency system. So over there the frequency will be constant. So Vi into Ii into T on equal to V of V0 minus Vi into Ii into T off. V output equal to V input into 1 plus T on upon T off equal to Vi upon total T upon T on T minus T on. So we are getting after solving the equation, we are getting that it will be V into I times 1 upon 1 minus T. Thus V output is always keeping as a greater than the input voltage. Just for that reason, it is called as a boost converter. So if we are saying about the power input, current input, and this one, so we are getting this kind of relations over here, and this will be the waveforms which will indicate about the input voltage waveform. ISW is volt current across the switch, where we have the two kinds of operation. One mode one, where the switch is on turn on stage, and the second mode where the switch is off state. So when the switch is off, then the current becomes zero. If the switch is on, then we are finding we are getting the current. So here we are getting the current, but in this case we are finding that there is zero current will be flowing because the switch is turned off stage. Similarly, the diode current, we are finding that the diode current is zero during the operation time and freewheeling diode current. And when the switch is off, at that moment we are finding that there is a signal is coming out. So the inductor, whatever energy is stored within the inductor, that will be discharged through this one. So the current will be flowing over there. So over here we are finding that it will be increasing in order, but in the case of the switch off time, the diode current will be decreasing. It means it will be discharged. So there is a charging mode and it will be needed over the discharging mode, right? There is the current which will be moving over here across the inductance. It will be flowing in an average. So the charging and discharging of the current in case of the inductance with switch on and off, the fluctuation will we are getting over the waveform. So this will be next waveform will be the current across the capacitor. Capacitor charging and capacitor discharging, which will be indicated in the downward. So once the switch is on and switch off, then the current, the magnitude of the current through the capacitor it will be varied. Then the output voltage again it will be varying in nature. So we are getting the voltage it will be twice of the input. So if we are taking the dotted part as a voltage, reference voltage. So we are finding that the output voltage is always more than the input voltage. So over here we are getting that the maximum possibilities of the voltage which are getting at the output point, it will be twice of the input voltage, right? These are the some relations which will be developed over here. V output voltage across the inductance is VL equal to VI equal to L times DII into dt. So if we are increasing this the voltage, then automatically we are getting that the maximum or I max plus I min equal to 2 times of input current. By solving I max, we are getting the I max equal to VI into 1 upon R1 minus D up square plus T on upon 2L. Right? Similarly, we are getting the I main. It will be Vi into 1 upon Rd minus 2 minus T on upon 2L. IPP means peak to peak to peak current. It will be the I max minus I main. For continuous current mode, it will be I mean equal, we are keeping I mean as equal to 0. So we are getting the value of the current of the inductance, that how much current we are required just to operate the system. So it will be RT on upon 2 into 1 minus D whole square. Next one is the buck boost chopper. It combines the concept of both the step up and step down chopper. The output voltage is either higher or lower than the input voltage. The output voltage polarity can also be reversed. The switch is either an SCR or GTO or IGBT. When S in on, D is reverse bias and ID is 0. The voltage across inductance is equal to the input voltage. The capacitor supplies energy to the output load. The current through the inductor increases linearly with time. If with S off, the source is disconnected. The current through inductor does not change instantaneously and it forward biases the diode, providing a path for the load current. Output voltage becomes equal to the inductor voltage. With S is on, W is on, so we are getting the W on or the power on, it will be VI into IA into T on time. Similarly, if we have to make it T off time, then W off equal to VI into IA into T off. By ignoring the losses, W on must be equal to the W off. If the time is equal, this will be the circuit diagram which will indicate that this will be a switch, inductance, capacitance, freewheeling diode, and the load. So this diode in the reverse action, so it will only allow the current which will be flowing through the capacitors toward load towards the source, or it will complete the path that to the capacitors and inductance. Never allow the current which is coming from the input side, it will be moving towards the load side directly, right? So first one, whenever we are saying that the device is under the off state, so the switch will be on and off state. At that moment, we are finding that the current which is flowing through the load, or it will be across the capacitor, it will moving through the diode, and it will moving towards the inductance. So it will follow this kind of path over here. While the switch is on, at that moment the supply is moving, not try to move towards the diode side, because diode is in the reverse axle. So it always is under the off state. And the current it will be moving through the inductance and follow a path like this. So the path will be completed like the supply voltage, switch, inductance, and then again supply voltage. The average output power is given as P input. If P input will be the V input into IN, or I max plus I mean upon 2 into dVi. P output equal to V output 2 upon 2 upon R. So I max plus I mean equal to 2 dVi upon R into 1 minus d square. So I max minus I mean equal to Vi upon L dt. I max equal to this, I mean equal to this. For the continuous current conditions, if we have this one again, the minimum current equal to 0. So that to identify about the inductance value, that value will be identified that when up to what time the minimum current it will be continued by the inductor. So the inductance will be identified as a specific value, so that the continuity over the output current will be maintained by the system, right? This will be the end of the lectures on the buck boost converters. Thank you.